when it comes to debating, hey, this is proportions, hey, this is percentages. Well, the plot twist is that percents and proportions are actually the same exact idea. They come from the same concept, and that is a ratio, comparing values that have factorial relationships. So here's how we can do this the long way, and here's how we can do this the easy way. So the long way would be, if we see this as a percentage, we want to know, hey, how many questions we need for a mark of 80%. So what that tells us is we're saying, hey, blank questions correct equals 80%. So essentially, my party people, if you're trying to write this as a percentage formula or a percentage question, you would write it like this. You would say 80% of all problems equals blank questions. Again, remember, when I tell you the percent formula, the percent times your original equals the result. The percent that you apply, the 80%, is the results you get. 80% correct is this number of questions correct. And so the only thing we need to do here is figure out what all problems is. Because we know that we answered 25 questions correct, and that's a mark of 20%. That's not all 100% of the questions. So notice, if we do it like this, we have to do more work to figure out what the original number of questions is. Then we plug it in. Then we get the number of questions here. So that's going to take quite a bit of time. And we actually don't need to do that. What we can do is this. I'm going to invite you to think about it in this way. So I'm going to move this over, make this smaller. And here's how I'm going to represent this. I'm going to say, hey, I see here 25 questions correct translates to 20%. So I'll say that right here. 25 questions equals 20%. And what I'm looking for in green is blank questions, I don't know how many yet, equals 80%. Everyone, is that okay with you? Just writing this comparison here. We know that 25 questions translates to 20% correct, and we're looking for the number of questions correct that translates to 80%. Everyone, what does this look like? It's a P word, not just a percent. This looks like a what? This looks like a what? When we compare the same things in the same way, questions to the percentage, questions to the percentage, this is a proportion. This is a proportion. And so I'll use the letter Q to represent this. But this is super straightforward, because remember, the key to proportions is compare the same things in the same way. So if you wanted to solve it one way, like this, 25 questions over 20% equals Q questions over 80%, you're more than welcome to cross, multiply, and divide. But you can get this question right very, very quickly by doing this. We notice right over here that 20% to 80%, everybody, what do you multiply from 20% to get to 80%? Right, that is times 4. And so if we're comparing the same things in the same way as proportions go, then the correct answer will go from 25 to the number of questions correct. That's going to be the same relationship, times 4. Everyone, 25 times 4 gives us what? That gives you 100. So 100 questions correct translates to 80% on this test. So that's how you can do it the quick way. Again, if you wanted to cross, multiply, and divide, you're more than welcome to, because if you would have, you'd get 20Q equals 25 times 80, and that would end up being what? 2,000. And now that we're here, we would then divide both sides by 20. And again, assuming you didn't make a mistake, then here we are, Q equals 100. So again, more than one way to do it. We could have set it up as a percentage. We could have set it up as a proportion. And I want you to know that we could set up percentages as proportions. Yes or no, my Porter people? Are we still on board? Does that make sense? Excellent. Excellent. Yeah, so this can be seen, this would be more so in unit 4 than anything, unit 4, which is percentages, but I can solve this as a proportion. So either way, you would be practicing this if you looked at unit 2 or unit 4. Again, you're going to find this, in unit 2 in the unit checkpoint, but it can be found in unit 4 as well. But again, it's up to you. It's up to the way that you think about solving it. All right, so let's take a look at this problem here. Now, this one's going to be a very, again, like I said, fundamental problem, but it's a very important one. So here it says, how many miles does she cover? A jogger runs at 6.5 mph, miles per hour, for 2 hours. Now, everyone, I have a question. Even though we don't see, what's the distance or what's the rate or what's the time, when we read this question sentence, how many miles, not miles per hour, not hours, but just miles, what is it that we're looking for? What are we trying to find here? Yeah, miles, that's a distance unit. Miles, inches, feet, kilometers, centimeters, those are just distance units. So the first thing you want to understand with word problems is, what am I looking for? What do I want? And that word miles there tells me that I'm looking for distance. Now, I don't think I need to ask, but I will, because I want us to really ingrain this in our heads. Everyone, the formula is distance equals what times what again? Yeah, that's going to be rate times time, RT, absolutely. So here, what I'll do is I'll write rate times time, and let's see if the problem gives me those values, which it does. It says a jogger runs at 6.5 or 6.5 miles per hour. That's our rate. The big giveaway is that word per. And then the time frame that we have here is 2 hours. So if we go ahead and just write everything out and calculate, we're done. So here we go. 6.5 multiplied by 2. If you want to go ahead and do this on the side, you absolutely can. Just remember that when you're multiplying by a decimal, just ignore the decimal. Calculate normally, bring the decimal back at the end. So 5 times 2, that's going to give us 10, and we'll carry that 1. From there, we have 6 times 2, which is 12, carry the 1, and that's 13. Now, I know this looks like 130, but what we want to do is make sure that we bring the decimal back. That's it. Calculate normally, bring the decimal back, and we'll get a nice, confident, correct answer of B, 13 miles after we multiply 6.5 times 2.